Let's start by looking at x squared plus 9. We have two terms, but they are being added, so this is not the difference of squares. If we had the binomial x squared minus 9, however, it would be the difference of squares, so we could factor it into conjugates. But how do we do this? First, remember that conjugates are binomials that are identical except for the signs of the second term. So we can start by writing down our parentheses and putting a plus in one and a minus in the other. As we've already stated, the terms in the conjugates are the same except for the signs in the second term. So when we look at the x squared, we know that it came from multiplying two identical things together. In this case, x and x. In order to find the identical numbers we have to multiply together to get 9, let's think about what we're really doing. We're saying, what number squared equals 9? If we recall our list of perfect squares, we can see that 9 is 3 squared. So, we need to put a 3 as the second term in each set of parentheses. Understand that really what we're doing with this is finding the square root of 9. And now we have our answer, x squared minus 9 equals x plus 3 times x minus 3. For our second example, consider the binomial 4x squared minus 5. While it is the difference of two terms, 5 is not a perfect square, so we can't factor this one. However, if we had 4x squared minus 25, we could. First, write down the parentheses with the plus in one and the minus in the other. Next, we need to find out what we can multiply by itself to get 4x squared. Notice that the square root of 4 is 2 because 4 is 2 squared. So, if we put a 2 and 1x in each set of parentheses, we'll have identical terms that multiply to get 4x squared, 2x and 2x. For the last terms, we need to find the square root of 25, which is 5 because 5 squared is 25. Now we have our final answer, 4x squared minus 25 equals 2x plus 5 times 2x minus 5. The next example of a binomial that is not the difference of squares is 16x to the fourth minus 121y. We have subtraction, and we recognize that 16 and 121 are both perfect squares, but the y does not have an even power like the x does. Instead, if we had the binomial 16x to the fourth minus 121y squared, we could factor it. After we write down the parentheses with the signs, we need to find the square root of 16x to the fourth. The square root of 16 is 4, and we can split the x to the fourth up evenly into x squared and x squared. So, 4x squared is the first term of each conjugate. To finish factoring, we need to put the square root of 121, which is 11, with a y, so we have 11y as the second term of each conjugate. Now we have the final answer, 16x to the fourth minus 121y squared equals 4x squared plus 11y times 4x squared minus 11y. Y is again the reason why our last example, x squared y cubed minus 81, is not the difference of squares, because it has an odd exponent. If it were even, like it is in x squared y to the fourth minus 81, then we could factor it. After we write down the parentheses and signs again, we can split up both variables evenly, giving us xy squared as the first term of each conjugate. The square root of 81 is 9, so 9 is the second term of each conjugate. Now we have our final answer, x squared y to the fourth minus 81 equals xy squared plus 9 times xy squared minus 9.